Hello students! Today we're looking at surface area of 3D shapes. So the first thing I want to say is that as we talk about 3D shapes and finding the surface area, I have a really helpful hint for you, which is to visualize the net of the shape. So if you see a cube, try and visualize it as its net, as a flat, two-dimensional shape. What are all the components that make up the two-dimensional shape? If you do this, finding the surface area is going to be a lot easier. So I have a few more examples. If we look at all of these nets over here, you can identify what the three-dimensional shapes are. So what I want you to be doing while you see these is working backwards and trying to say, okay, if I have a rectangular prism, this is what my net's going to look like. Or if I have a cone, this is what my net's going to look like. If I have a triangular pyramid, this is what my net's going to look like. So being able to visualize the shape flattened as its net is really going to help. Okay, so the first shape that we have is a rectangular prism. So I'm going to sketch what the net's going to be off to the side. I know that there's going to be longer shapes and shorter shapes. So now I'm going to start finding the area of my two end pieces. I'm going to start with these two smaller squares. And they're not exactly squares because when I look up here, I can see that the length is 5, but the height is 3. So we're dealing with a shape that's 5 by 3. And when we use our formula of base times height, we know that this area is going to equal 15. So since we have two of them, we're going to multiply this by 2 to get a total area of 30. So this area of 30 represents our two small side pieces. So I'm just going to make a note over here that these are my sides. Now I'm going to move on and I'm going to find the area of the top and bottom pieces. So it's hard to see, but there's a top and then underneath there's a bottom piece that's equal to that. Now this rectangle up at the top, I have to be very careful and look to see where the dimensions are coming from. I know that this side here is going to be the same as this side here, and this is 5 inches. So I know that the length is going to be 5 inches, and I can see that the width across is going to be 9 inches. And because it's the top and bottom of the piece, I know that the bottom of the piece is going to be this rectangle here, and the top piece is going to be this rectangle here, because you see if you fold it, they'd be the top and bottom. So this second piece of information is going to be 9 by 5. So again, we're going to use our same area of base times height and just multiply these together to get 45. But then we're going to multiply by 2 because there's 2 of these sides. 45 times 2 is 90. And this piece of information is the top and bottom. So I'm just going to notate that next to there as well. Okay, and our last piece of information that we're trying to look for are the front and back faces, which would be this first rectangle that we see. So if I look closely here, I know that 9 is going to be my bottom length, and I know that my height's going to be 3. So my second set of rectangles are going to be slightly different because they're 9 by 3. So again, it's really important that we pay attention to these. So these final shapes that I'm shading are the bases. So this is going to be the front and back of my net. And again, we're going to multiply base times height. 9 times 3 is 27. And again, we're going to multiply that by 2, which is going to be 54. And this represents the front and back. So now what we need to do is take all of these found areas and add them together. So we have 30, 90, and 54. So let's do that. So we're going to take 30, 90, and 54. Well, I know that 30 and 90, I can just think of it as getting rid of the zeros. 9 plus 3 is 12. Add the 0 back, it's 120. And then add a 54 to that. oops, let's keep an addition sign here so we know what we're doing. Add up the ones place, add up the tens place. So 174, and when I look back at my initial problem, I know that it's inches. And because it's surface area, because it's flattened, we're going to stay inches squared. So my final answer is surface area equals 174 inches squared. Okay, so in this shape, we want to find the surface area of the triangular prism. So I'm going to start solving this the same way by drawing the net. So you have to kind of visualize what this is going to look like unfolded, but I can see that I'm going to have a long rectangle. That's kind of my front piece. And coming off of that to the side are going to be my triangles that are right angles. So I'm just going to notate that here. Even though they don't look perfect, they look far from perfect, but it'll help us to visualize it. And then there's one of the sides, that's the 3x2 side, and then there's another longer side. So this just gives me a general idea of what my shape's going to look like. So again, the first thing I'm going to do is try and find the surface area of all the sides and add them together. So let's start by looking at the surface area of the bases, which is going to be the triangle. So that's going to be the bottom, and then that's going to be my top as well. So if I look closely, I have to look and see, okay, well, this dimension here lines up with this dimension up here. So that's 3. This dimension here lines up with this dimension there. That's 4. And so I need to be able to find my base and my height of my triangle. Well, if I just look at it a slightly different way, if I think that this is the base and this is the height because it's a right angle, then I have enough information. So I'm looking at 3, that's going to be my base, and 4 is going to be my height. And the key here was that they drew those little right angle signs. That was really helpful. So right triangle, base of 3, height of 4, and now we're going to use our formula for triangle, which is area equals 1/2 base times height. So let's plug that in. Area equals 1/2 3 times 4. I know that 3 times 4 is 12. So half of 12 is going to give us 6. But remember, there's 2 of these. We're doing 2. We're doing the top and the bottom. So 6 times 2 is 12. Okay, so 12 is the total area of the triangle. So I'm just going to notate that to the side. And now I'm going to move on to find my other pieces. Now, these other pieces aren't similar. They're each different, so we need to look very closely. So let's start by finding our base, which is the one we started with. So this is our front piece right here, which is going to be this front rectangle, the longest rectangle. So when I look closely, I can see that 2 is here, and the bottom number just happened to get cut off, so this bottom length was 5. So we know that our rectangle, our front rectangle, is going to look like this, and the long side is going to be 5, and the height is going to be 2. So to find the area of a rectangle, we use a different formula. Area equals base times height. So in this case, 5 times 2 is 10, and we're not going to multiply it by 2 because there's only one side. Okay, so now let's look at the other sides kind of carefully and see what we can figure out. So let's start with this side here. Okay, so that side is going to match this back side over here, and if I look closely, I can see the top is going to be 4 all the way across, and then the height's going to be the same height all the way around, which is going to be 2. So our next rectangle is going to be 4 by 2. So our formula is area equals base times height, which is going to give us 8, and we don't have a repeat of that. And let's find our last rectangle over here. So now we're kind of looking at this back side of the rectangle, which is going to be 3 across the top and 2 tall. So I keep shrinking each time. And again, we're going to use base times height as our formula, which is going to give us 6. So similar to last time, we're going to add all these up and find our answer. So we have 12, 10, 8, and 6, and I can do some of this mentally. I know that 12 plus 10, that's going to be 22, and I know 8 plus 6, that's going to give me 14. So I can do a little bit in my head to help me out. And then my last step is going to be adding those together. And so my final answer, the surface area of this shape is going to be 36 inches squared. And the squared is because it's really two-dimensional. It's really a net. It's really flattened. So don't get confused with that. Any surface area answers are going to be in inches squared.